what were your biggest challenges while you were working with the GSLV missions?
See, I would say the rocket technology is tricky. Even Elon Musk, the chief of the SpaceX Corporation, he said this word in spite of his mammoth success. Even if one additional comma extra, if it is in the software, or additional machining of the hardware to the extent of few microns, it will jeopardize the total rocket missions. So these are the intricacies of the rocket technology development. The biggest challenge in GSLV, I would say, is the breakthrough of the indigenous development of the cryogenic stage, especially after 2 consecutive failures of GSLV missions. We spent more than 3 years on this redesign, a thorough analysis, expert analysis, even from abroad, from Moscow, the testing of each subsystems, and finally successful launching with our own indigenous cryogenic stage in the GSLV D5 GSAT-14 mission on the 5th of January 2014 in Sriharikota. That was a cherishable moment for ISRO, and I would say it was a turning point for ISRO. I would also say at this point of time, during that time I was supposed to attend my son's convocation of his MS degree in Arizona State University in the United States. But I need to cancel it and participate in the very important mission of this GSLV D5. So this is the situation with which we forgo our personal things and support the ISRO's missions.
That's very nice of you, sir. We honor your dedication and sacrifice towards our country. Can you explain the importance of simulation systems in rocket launches in simple terms or in layman terms for our viewers?
Yeah, simulation is the backbone for the success of every rocket mission. I would say in simple terms, the rocket as we watch in real time is simulated in a computer test bed. And this serves as a pre-check for its correctness or thoroughness before we launch it. So to do this, various models of the rocket systems like a propulsion model, the very important aerodynamics model, the wind modeling, the earth modeling, that is the gravity model, all are embedded such that the computer simulations will actually simulate the trajectory of the rocket. Hence, there is no compromise on the number of simulations. One flight we did this many, so we can reduce to the next flight. No. We also do off-nominal simulations to characterize the rocket performance in total or completely. So this is what the simulations we undertake for every rocket launches.
Sir, you have played a major role in reusable launch vehicle project. How important it is to reusable rocket technology for the future of space exploration?
See, as you know, the space shuttle developed by NASA, they developed 5 space shuttles: Atlantis, Endeavour, Challenger, Columbia, and Discovery. And there is an orbiter which comes back from the orbit, re-enters the dense atmosphere and lands like an aircraft, and it can be reused for 100 missions. This is not only saving a large expenditure, but enables frequent launches. The turnaround time is cut short. So many missions we can accomplish, and also enables ambitious deep space infrastructure. You can take deep space, for example, the space station. Very fast you can build the space station there. A fully reusable transportation system serves as a backbone for establishing permanent bases on the moon and executing cargo or crewed missions to Mars. So this is the need of the future, and it minimizes discarding massive, expensive hardware into the ocean. If Bay of Bengal, we are dumping so many spent stages, and some are in the orbit also. So these are the things that played. A reusable launch vehicle helps us, and a fully reusable launch vehicle should be attempted, and that will give the 100% benefit for us.
So, what were your findings while working on some of India's most important space missions?
Yeah, the learning lessons. One is by our own innovative way, and also by failures. Failures are the stepping stone for success. So in this way, I would narrate here, number one, the way of maximizing the potential of the existing launch vehicles of ISRO and minimizing the budget, minimizing the testing. ISRO could accomplish the Mars orbiter mission. You know, the Mangalyaan satellite. Okay. The budget of the Mars mission is less than the autofare per kilometer, like that it was told. So this is the one thing, learning lesson, and utilizing our own resources, the launch vehicle and other things. Number two, the necessity for more robust design is required. Also, the rigorous ground simulations and improved landing technologies. Because this we learned in a hard way from the Chandrayaan 2 mission. As you know, when it was touching down the moon's soil, it was crash landed. Okay. So some kind of robustness we need to build in to avoid such failures. And in Chandrayaan 3, it was a complete success. So this is a type of learning exercise we had. And then lastly, as a person worked in most of the ISRO launch vehicles, some of the launch vehicle failures, observing that there is no compromise to be made on any of the quality of the space deliverables in terms of the software, the life-limiting components, or the hardware machining. It should meet exactly the critical dimensions. So these are the aspects we learn from our experience, from success and failures both.
Can you explain in brief about your assignment in Moscow and how it helped ISRO?
See, this opportunity has come because of the two earlier GSLV mission failures with the cryogenic stages. One with our own and the other one with the Russian cryogenic stage. So this made us to look at a complete revisit on the aerodynamic characterization of GSLV and its variant configurations, and that has led to visit of two teams to Moscow to test the GSLV models. We carried fabricated models from India and taken to Moscow. During the month of December, we were settled down in Moscow, and we visit their laboratories, the wind tunnels, put our models, and test the wind tunnel tests, the steady and unsteady pressure measurements. Large amount of data were generated, and you know the climate also, inclement weather conditions, minus 7 degrees Celsius. But our team worked day and night and taken all the data. And then after that, what we did, we collaborated with the in-house generated data. There is a wind tunnel laboratory, National Aerospace Laboratory in Bangalore. So we generated similar data there also. So make a correlation. Not only that, it was reviewed by a national review team. instituted a high-level team consisting of the experts, professors from IITs, various IITs, the R&D institutions, and from our own Indian Space Research Organization. And I happen to be the member secretary of the high-level team, reviewed thoroughly, and the new data we have taken, and after that it was successful.
Great, sir. So behind every success, there are a lot of failures. What is a hypersonic wind tunnel, and why is it important in aerospace research?
From the time I joined in ISRO, all along I was in the launch vehicle projects, rockets development, design, simulation. But in the last part of my career, that is the last 3 years, I was appointed as a project director of the hypersonic wind tunnels project we call HWTP. It was a high value project, and it was taking much more time than the expected, a lot of CAG queries, and hence need to be solved. What are the hindering problems not progressing? Get the fabrication done in the work center, the major contractor being the Larsen & Toubro Mumbai, and number of industries we have to interact, dialogue with them. It's a very tough job as a project director, and after that, get the systems, direct it in our test facility in Antuvan, and test and evaluation of it, we have to be doing it. It was a good support and guidance given by the director of the center, Vikas Sarabhai Space Center, Dr. K. Shivan. Eventually, he was the chairman of ISRO, and the deputy director of the aerodynamics, Dr. S. Pandian. He became later as the director of the Sirigirigota Center, and along with the other dedicated project team members. I had a very dedicated team members, very intelligent team and committed members. So through whom I could finally demonstrate the high Mach number, that is Mach number 12 blowdown successfully in the presence of ISRO chairman and other members on 20th of March 2017, well before my retirement. The completion and closing of the project during my tenure was a real retirement gift, okay, than the retirement benefit I received from the organization or the government. Okay. So this is just an introduction I would like to tell. But coming to the definition of a hypersonic wind tunnel, in simple terms, it's a ground-based test facility which propels air at speeds of Mach 5 to Mach 12. So almost 15,000 kilometers per hour, the air has to be sent over a scaled models of aircraft or a spacecraft. So this facility is very much important for testing the aerodynamic thermal characteristics of the re-entry vehicles. For example, the Space Shuttle recovery module in orbiter re-enters. Similar modules when it is re-entering from the orbit. Other things is the testing of air-breathing buckets, multi-body separation systems, etc. It is facilitates. This facility gives the test data for those configurations.